7-6 is rational exponents. This word rational here really just is a fancy word to describe a fraction. A rational number is anything that can be written as a fraction, and so that's what we're talking about here. And it's kind of interesting to see what happens when you've got a fraction as a power. Rational exponents, that's what we're dealing with here. Okay, so for any non-zero real number b, and for any integers m and n, these here are equivalent. So your base b has this rational exponent, m divided by n, that's all in the power there. It really just represents a root or a radical. So b to the m over nth power equals, notice where the n and the m's end up. It ends up being the nth root of b to the m power. So this bottom number here, n, really just represents the index, represents what root you're taking. And then here's another way to write it too. You could say in parentheses we've got the nth root of b. Take that first and then raise it to the nth power. All of these are equivalent ways of writing the same thing but just in different forms. So we're first going to practice converting between the forms. So example 1, we're starting with radicals. We're going to rewrite them in exponential form. So how do you do this? Well, in the first one, I've got the cube root of y, and this is y to the first power, by the way, the cube root of y. This index out here really represents the denominator of your fraction. You're going to say, okay, my base is y, it's y to the first power, and it's a cube root. So how do you write it as a rational exponent? You just say it's y to the 1/3 power. Easy as that. If you've got a fourth root, your power would be 1/4, and so on. But what happens if you've got something like c to the 7th, and then that's under the 8th root sign? Well, this 8 out in front, this index, really represents the denominator of your rational exponent. So your base is c. It's c to the 7th power, but then we're going to divide it by 8. So you've got c to the 7/8 power. Okay, so that's how you go from radical to exponential form. Let's go the other direction now, starting with exponential form in these rational powers here. How can we rewrite them using a radical sign, a root sign? Well, a to the 1/4 power really just represents the fourth root of a to the first, or a. And x to the 3/5 power really just represents the fifth root. That denominator there tells you what your index is. What root are we taking? It's the fifth root of x cubed. And that's how you convert back and forth. This will become a powerful trick when you get into simplifying some radical expressions. Okay, so now evaluating. When they say evaluate, they want you to calculate the answer, and you can do this very quickly on your calculator. So if you have a graphing calculator, you would type in 16 to the power of -1/4. You just got to make sure that you're using parentheses around these rational exponents. 16 to the power of -1/4. If you want to do it by hand, we can definitely do that. 16 to the -1/4 power is the same as 1 over 16 to the 1/4 power. That's how you want to rewrite those negative exponents. Create a fraction, 1 over 16 to the 1/4. Now, think of this as a root and not necessarily as a power. The 1/4 power really represents the fourth root. So we're taking the fourth root of 16. I know that's 2, and so our answer is 1 over 2, 1/2. Let's say you wanted to calculate 243 to the 3/5 power. Again, you could get your answer really quickly on a calculator, but if you didn't have a calculator, maybe you would go through these steps. This really represents a fifth root. Fifth root of 243 cubed. What is 243 cubed? You could go through that, then take your fifth root, or I could say that 243 is really just 3 to the 5th power. So I've got the fifth root of 3 to the 5th power cubed. Maybe you don't want to think about it this way. So what do I really have? I have the fifth root of 3 to the 15th power. 5 times 3 is 15. I'm just using laws of exponents here. And then we can say that this is just 3 to the 15 over 5, or 3 to the 3rd power. And I've kind of reduced it all down into 3 to the 3rd, or 27. Just one way to do it. There's so many different ways to do these problems. You could have worked with the fractional power here, or you could have used roots like I did, and laws of exponents. All right. If I were you, I would just type it in on my calculator and get your answer quickly. On to simplifying. These are not as easy. You cannot use a calculator for these. You just need to to know your math and your laws of exponents and how to convert from radical form into exponential form. Okay, so this first one is actually pretty easy. We've got a common base of x, and we know from the laws of exponents that I can combine the powers by adding. And we're lucky here because we have a common denominator. Remember that anytime you're adding or subtracting fractions, you have to have a common denominator. So I'm taking x as my base and then adding 1/5 plus 7/5. That's the same as x to the 8/5 power. Now we're done. Okay, if you can reduce your fractions, you will, but in this case, we can't. This one's a little bit different. I've got a negative exponent again, and what that means is y to the negative 3/4 is the same as 1 over y to the 3/4 power. That's how you rewrite those negative exponents. It doesn't mean your answer is negative. It means move it to the denominator of the fraction. Okay, now, if you remember from the last section here, let's rewrite this as a radical. Y to the 3/4 power represents the 4th root of y cubed. That's how you would rewrite it as a root. Well, we can't leave a root in our denominator. So what can you multiply by to get rid of the root? Well, in this case, you want to ask yourself, what can I multiply top and bottom by so that I no longer have a rational exponent? Basically, make it a whole number. Well, 3/4 plus 1/4 gives me 4/4 or 1, so I know that if I multiply by y to the 1/4 power over y to the 1/4 power, this will rationalize my denominator. Let's see what we get. In the numerator, I've got y to the 1/4. In the denominator now, if I add these powers up, I get 4 over 4 or 1, so I just get y to the 1st. Keep the common base, y, add up the powers, you get y to the 1st. Now I've rationalized the denominator, and remember we need to do that because we can't leave roots, radicals in our denominator, and for that reason we can't leave rational powers in our denominator, so you need to rewrite it so that the denominator has a whole number for its power. Kind of tying that into what we did in the last section, it's the same thing. I would have multiplied by the 4th root of y on top and bottom, so that I got the 4th root of y over the 4th root of y to the 4th, and we can still cancel this out and get y. So it's really the same thing. Here it's written using a radical, here it's written using a rational exponent. Okay, I've got a few more for you. How about this one? The 8th root of 81 over the 6th root of 3. Well, this is kind of confusing here because I've got an 8th root, that's really complicated. 6th root is really complicated as well. And these don't simplify. The other, at least the denominator doesn't. But the other issue we have too is that I can't really divide these because I don't have a common index. I've got an 8th root over a 6th root. So how do we deal with that? Well, you might want to change these into rational exponents to start. So what's the 8th root really mean? Well, that means the 1/8 power. So I've got 81 to the 1/8 power over 3 to the 1/6 power. So we're rewriting first into rational exponents. The next thing you want to do in order to simplify a fraction here, really anything using the laws of exponents, you typically need a common base. And so I've got a base of 3 in the denominator, and I'm going to ask myself, can I rewrite 81 using a base of 3 so that they match, so that I've got a 3 over a 3? Well, I think I can. 81 is the same as 3 to the 4th power. So I'm going to rewrite 81 as 3 to the 4th, and that's to the 1/8 power yet. And then it's over 3 to the 1/6. Okay, so I've managed that. I've got them both written as base 3. Now, laws of exponents again say that if you've got a power to a power, you can multiply them, and 4 times 1/8 would be 4 over 8, or 1/2. So now I've got 3 to the 1/2 power, simplifying that, over 3 to the 1/6. And we're not done here, we're not done yet. One more little law of exponents here says that if you've got the same base, you can keep the common base and you can subtract the power. So now I'm doing 3 to the 1/2 minus 1/6. Now I need common denominators here, so how can I get a common denominator? Well, I'm going to multiply top and bottom here by 3 because my common denominator is 6. So doing all paper pencil math here, I'm subtracting, my base is 3 and I'm subtracting powers 3/6 minus 1/6. That gives me 3 to the 2/6 or 1/3 power. 3 to the 1/3 power. So dividing these out here, look at all the work we did. We first rewrote it as a rational exponent. Then we got a common base of 3. Then I used some laws of exponents. Power to a power, we multiply. When you divide two like bases, you can subtract their exponents. And then finally, we worked it down into 3 to the 1/3 power. This is also equivalent to the cube root of 3. So either way you want to write your answer is fine with me. Okay, we got a couple left. This is the 4th root of 9z squared. Now, at first glance here, it kind of seems like nothing really simplifies. What's the point of simplifying this here? Well, we can actually reduce this down. Let me show you how it works. Again, I'm going to start by rewriting this using a rational exponent. So my index is 4. That means that 9z squared is to the 1/4 power. Okay, now the next thing I'm going to do is rewrite it so that I've got 9 to the 1/4 and then z squared to the 1/4. So 9 to the 1/4 power times, I'm basically splitting it up, splitting 9 and z squared up. Now if I take z squared to the 1/4 power, again, that's a power to a power, I can multiply them together. 2 times 1/4 is a half, so I've got z to the 1/2 power. That's where I'm at. 9 to the 1/4 and then z to the 1/2, and I got that by multiplying. What's going on? Okay, get rid of that. Now, can I simplify this 9 to the 1/4 power? Well, anytime you can rewrite something using a smaller base, you should do it. So I know that I can rewrite 9 using a power. 9 is the same as 3 squared. You want to reduce that base. So instead of using a base of 9, I'm using a base of 3. So I've got 3 squared. I gotta get my pen back. 3 squared to the 1/4 power times z to the 1/2 power. We'll just kind of leave that one alone. Well, if I take 3 squared to the 1/4 power, again, I can multiply this power times the power here. And I actually get 3 to the 1/2 times z to the 1/2. Well, that's kind of cool because now they have matching powers, and I can rewrite it as 3z to the 1/2, or we could say it's just the square root of 3z. Isn't it? Kind of cool. Now it's all simplified out. So the 4th root of 9z squared actually turns into the square root of 3z. It kind of makes sense when you look at the original problem and then what we ended up with down here. Let me show you one more, and this involves division here. I've got more than one term in the denominator here, also in the numerator, but that's kind of beside the point. We need to think conjugates again. How can I rationalize this denominator? Remember, this really represents a square root, and I cannot leave any radicals or any rational expressions in my denominator. So we have to use the conjugate of m to the 1/2 plus 1, and that is m to the 1/2 minus 1. All you do is switch that middle sign. I'm going to multiply the top and bottom by the same thing so that I'm really just multiplying by 1. Okay, so we're going to use FOIL here. Use the distributive property. M to the 1/2 times m to the 1/2. When you're multiplying like bases, you combine or add the powers. So I get m to the 1st, because 1/2 and 1/2 gives me 1. Then I'm going to take the outside terms. M to the 1/2 times -1. That's minus 1 m to the 1/2. Then the inside terms. -1 times m to the 1/2 is minus 1 m to the 1/2. Then last times last, -1 times -1 is positive 1. We'll simplify that later. Okay, in the denominator, I've got m to the 1/2 times m to the 1/2, and again that gives us m to the 1st. Then you've got m to the 1/2 times -1, that's -1 m to the 1/2. Positive 1 times m to the 1/2 plus 1 m to the 1/2. And then 1 times -1 is -1. Okay, so we've got very similar things going on in the numerator and denominator, but they simplify a little differently. In the numerator, I've got m. Then I've got like terms here. I get -2 m to the 1/2, and then plus 1. That's my numerator. Denominator, the inside terms here cancel out because you've got a negative and a positive. m to the 1/2. Those cancel out, so we just have m minus 1. Nothing else here reduces, so there's where you leave your answer. Okay, so a lot of the ideas that we're doing here are the same as previously, except for we're not using radical signs. We're not using roots. We're using rational exponents, and it means the same thing. Sometimes they're actually easier to work with. So we'll continue practicing this more on Monday.